All right, well, what's another operation maybe we could do with radicals? How about multiply? Yeah, we can multiplying radicals. Okay, all right, now if I have 6 square root of 2 times 5 square root of 3. Be aware that multiplying is different than adding and subtracting. We can multiply things that aren't like. For example, I can multiply 8x times 4x squared. Even though those aren't like terms, I can multiply them, right? I multiply them, I get 32x to the third. So in multiplying, you don't have to have like radicals. Only on adding and subtracting. It's 32x to the third. So, guess what here I get when I multiply 6 square root of 2 times 5 square root of 3? 30 square root of 6, yes. 30 square root of 6. 6 times 5, I multiply it because it's outside the square root. And then I multiply the square root parts. Yep, so I get 30 square root of 6. So multiplying, you can multiply anything together as far as the radicals go. And you multiply the inside parts together, multiply the outside parts all together. Now, sometimes what happens, let's say we've got 4 square root of 2 times 8 square root of 10. 4 square root of 2 times 8 square root of 10. Well, same thing, 32 square root of 20. But what do you note about square root of 20? Square root of 20 can be broken down a little more. Yeah, sometimes when you multiply radicals together, you can simplify the square root part like we've encountered before. You with me on that? 32 square root of 20. See where I got that. But I can break down the square root of 20, can't I? 4 and 5. And so that would be 32, and the square root of 4 is 2. So I have 32 times 2 square root of 5, which is 64 square root of 5. So you're still looking to simplify your radicals if that comes up. Okay? All right, now, yeah, these radicals, we can do basically the same thing as we do with, like I said, with polynomials. 2 square root of 3, I'm going to multiply it by 4 square root of 2 minus 8 square root of 5. If I've got a radical term in front of parentheses like that, what do I have to do? Distribute it. Yeah, I've got to distribute it. I've got to multiply the 2 square root of 3 times both things. If I do 2 square root of 3 times 4 square root of 2, well, that's back to our previous discussion there. What do we get there? 2 times 4 is 8. Square root of 3, square root of 2 is square root of 6. Then I have to do the 2 square root of 3 times the 8 square root of 5. 2 times 8 is 16. Square root of 3, square root of 5 is square root of 15. So I get this, 8 square root of 6 minus 16 square root of 15. And is there anything I can do more with that? No. Don't have like radicals. If I wanted to subtract them, I'd have to have like radicals. I don't have that, and there's nothing simplified that I can do as the radicals. So that's it. Just distributing there. square root of 6 times square root of 10 plus the square root of 6. Again, it's just a distributing, isn't it? What do we get? Square root of 6 times square root of 10. Square root of 60. Square root of 6 times square root of 6. Square root of 36. Yeah, even though we haven't done one where we had the same radical, but yeah, if you multiply the same radical by the same radical, a radical by the same radical, you still multiply there. It's still square root of 36. Okay? Now, these do happen to simplify, don't they? This one, it's not a nice square root, but I can simplify it. Again, it has a 4 factor in it, so let's do 4 times 15. So that breaks down to 2 square root of 15. And then nicely, this one, yeah, that one simplifies real nicely. Okay, question at all about that? Okay? All right. All right, so let's say we got 4 square root of 5 plus the square root of 3 times the square root of 5 minus the square root of 3. What do you see happening there? Distribute again. What's the usual word? FOIL. Yeah. Yeah, this is basically two binomials, binomial radicals. And when we have binomials like that, the word of the day would be FOIL. Yeah. So that would mean take the 4 square root of 5 times, first of all, the square root of 5. So that would give me 4 square root of 25, wouldn't it? Basically 4 times 1. And then square root of 5, square root of 5, square root of 25. Then it would take the 4 square root of 5 times the minus square root of 3. What would that be? Well, it's 4 times minus 1, so it would be minus 4. And then square root of 5, square root of 3 would be square root of 15, wouldn't it? Then I have to do inner, so that would be 3 square root of 5, 3 square root of 3 times square root of 5, which is square root of 15. And then square root of 3 times minus square root of 3, that would be minus the square root of 9. Okay. Now there is some simplifying to do. This right here simplifies. Square root of 25 is 5, so that's 4 times 5 I have, so that's 20 right here, isn't it? Also, notice, what about in the middle two here? You add them? Yeah, those are like radicals, aren't they? I've got square root of 15. I've got another square root of 15. Negative 3 square root of 15, is that what you're saying? Yeah, negative 4 plus 1 is negative 3 square root of 15. And then this one, well, that one's just minus 3. And then, of course, I've got 20 minus 3. That's 17. So I get 17 minus 3 square root of 15. They won't all necessarily simplify as nicely as that. Usually depends on what all you have. If I have the square root of 2 plus 3 square root of 5 times square root of 3 minus 4 square root of 6, say. Pull that out. square root of 2 times square root of 3 is square root of 6. Square root of 2 times minus 4 square root of 6 would be minus 4 square root of 12. Then do the 3 square root of 5 times square root of 3. That would be 3 square root of 15. And then 3 square root of 5 times minus 4 square root of 6. What's that going to be? 3 times minus 4 is minus 12. Square root of 5, square root of 6 is square root of 30. With me on that? And then the only thing I can do with that, see anything I can do with that? Saying simplify this? Well, yeah. No, it's just your square root of 2, square root of 15 won't simplify. Because square root of 2 is not simplifiable. I think I see what you're trying to do, but yeah, since I can't simplify the 2 square rooted, I'm going to leave that one alone. Okay? This one, how about this one? Square root of 12. 4 and 3. Okay, so this will be 6, and this will be minus 4. That'll be square root of 4, square root of 3, which is minus 4 times 2, square root of 3, so it'll be minus 8 square root of 3. That's the only thing I can do with this. So this one turns out to be a longer one because none of them are like radicals. Can't get them to be the same. All right. Another thing we've encountered along the way is squaring. Something like this. What do you think the best root to take on that one would be? 6 plus 4 square root of 3. I want to square it. Do another copy. Yeah. Okay. Because it's basically two radicals there, binomial is what I've got. Best thing to do is write it twice. And FOIL, yeah. Write it twice, and you're going to have to FOIL it. Yeah, this is another FOIL. Okay, 6 times 6 is 36. 6 times 4 square root of 3, well, you just do the 6 times 4, wouldn't you? 24 square root of 3. Then 4 square root of 3 times 6 is 24 square root of 3 also. And then 4 square root of 3, 4 square root of 3. Well, 4 times 4 is 16. Square root of 3, square root of 3 is square root of 9. So yeah, you wind up with this, and then simplify this because, again, in the middle, doesn't always happen, but we can combine those, can't we? They're like radicals, so I can add them. So we've got 48 square root of 3 right there in the middle. And then your square root of 9 is just 3, so this is 48 on the end, isn't it? 16 times 3. Which I can combine with 36, right? 36 and 48 is 84. So 84 plus 48 square root of 3. Question?